So in this video, I'm going to be looking at doing the work breakdown structure and a network diagram for a simple product. And my simple product is a solar-powered microcontroller-based weather station. And so the first step is to try and figure out the product scope. So I'm going to draw a block diagram here so I can get an idea of the systems and parts that make up my microcontroller-based weather station. So let's draw an outside box first. This is the container. And in this, I'm going to have my microcontroller. I'm using an Atmel. I call it Atmel. And connected to that will be some sensors. So they're coming outside the box. And these might be sensors like rainfall monitoring, humidity, temperature. And it's going to be solar powered. So I'm going to need a battery. The battery is going to be inside the unit. My battery here. And I'm going to need a solar charge controller. So here I'm just calling this a regulator. So that's going to connect to the battery. And that's going to go outside the unit to some solar panels. And then also it needs to be internet connected. So we're going to have a router outside the unit. And the router is going to need some power. And it's also going to be connected to the Atmel for data. So there you go, a very simple block diagram. So the next step in this process is to figure out our work breakdown structure, which includes all of the activities that we need to complete in order to realize this product. So what we've done here is we've got an idea about what the product scope is. And the next thing is to move on to the work breakdown structure, which will enable us to work out the project scope. So let's leave that there and we'll get a new piece of paper. Make sure we'll take that away. So let's look at building up our work breakdown structure. So WBS. And so at the top of this, we want to write down what our product is. So this is a weather station. And in this particular work breakdown structure, we're going to take the product approach or the deliverable approach. So we're going to list down all the subcomponents that make up this weather station that we determined in our block diagram. So we're going to need, what was first? Solar panels. We need a battery. Going to need our router. There's also a charge regulator, solar regulator. We need our sensors. And we also need our microcontroller, and I'm calling that the Atmel. So we're doing the hierarchical work breakdown structure here. I'm going to connect these up. These all need to be done. And so now we need to work out the activities that are needed to be achieved under each of these. I guess you could call them work packages. It depends how far you want to break down the work breakdown structure. But let's call these work packages, and now we'll work out the activities that come under each of these. But first off, we need to put in our numbers. So we don't have a number on the top one, but the solar panels is going to be 1.0. 2.0, 3.0, 4.0, 5.0, and Atmel 6.0. And so we need some activities for these. So I'm going to do it by process. So I've done it by product, and now I've decided that at this level, I'm going to work out the activities by process. So the first one on the list is I'm going to need to order some solar panels. So order solar panels, it's going to be 1.1. Order solar panels. 1.2 will be install on roof when they arrive. Okay, let's move over to the battery. I need to order the battery. So that's 2.1 order battery. 2.2 is charge battery. And then I'm going to move through these. So router, I need to order the router. 3.1 order. 3.2 install. The regulator, 4.1 order. That's all I'm doing for that one. Then on 5, for sensors, I'm going to 5.1 order sensors. 5.2, I'm going to connect the sensors to the atmel. I need to connect them at some point. The atmel, okay, so 6.1, order the atmel. Then I'm going to do some software programming of the atmel. So I've called this 6.2 application setup. Then I'm going to write the sensor libraries because I need to program the interface to the sensors. And then I'm going to run some sort of test on that, on the sensors, test sensors. Okay, so now we need to put this all together. So where are we going to do that in here? I think it's probably best that we add another item to our list. And here we're going to call this testing and commission. So we've broken our rules a little bit here of having these as sub-products. I'm now adding a work package for actually putting this all together. So there's many different ways of doing this, but this seems reasonable and logical in this situation, so let's proceed. So there's going to be all sorts of testing that needs to be done here. So I'm going to need to do some sort of test for the power with the solar panels, the battery, and the router. So I'm going to call that 7.1 power test. So I did prepare this earlier, and I discovered that I'm going to need to connect the router. I want to do some sort of field test. So I'm going to do that 7.3 field test. So after I put everything together, I've also need to do some sort of lab test as well. So the thing about the work breakdown structure is they don't actually need to be exactly sequential. You work out the dependencies and the order of the activities when we do the network diagram next. So it's okay if these are not exactly in order. It might be that some tasks are dependent on multiple other tasks, so it's not able to, there might be not just one sequential order for all of your activities. So 7.5, I'm going to do a second test. I'm going to call this a beta test. And then finally, I need to commission this system. So I'm going to do 7.6 commission. Okay, so that's a very basic work breakdown structure. Okay, so now we've done our work breakdown structure. We worked out the activities that we need to complete in order to build this system. Let's actually try and do our first pass of the network diagram. And so we're not worried about durations or about the critical path or the length of time that the project will take just yet. Let's just try and figure out the steps involved in the network diagram. So I've got the work breakdown structure here next to me. You would have seen that in the earlier part of the video. So first off, I'm going to do the blocks that show each of the starting points for the different products. And so there's actually 6 of them. So I'm just going to draw them down first because we know they're all going to start at the same time or have the potential to start at the same time. Yep, so here they are. So we've got 1.1. This was ordering our battery. We've got 2.1, which is order solar. I'm going to try and go fast here. So 3.1, order router. 4.1, we're going to order our regulator. 5.1, we're going to order our sensors. And 6.1, we're going to order the atmel. So the next task for the battery was 1.2 was to charge it. Charge battery. And then we're going to install the solar. Yep, okay, install solar. So it was 2.2. And we ordered the router, then we're going to need to install the router. $3.2. And then I'm going to jump down to connect sensors because I ordered the sensors. We need to connect them up to the atmel. 5.2, connect atmel. And then I'm going to jump down here. So the process, I'm going to be jumping into software now. So I'm going to program the microcontroller. 6.2 application setup. Yep, and then my next step was to program the sensor libraries. That was 6.2 sensor libraries. And so I'm going to need to connect the sensors here. So I'm going to draw some arrows in now. So I ordered the sensors, I've got to connect them, and then that feeds into here, into this task here, so programming the sensor libraries. So after the programming's done, I need to test those sensors with the atmel microcontroller. So 6.4 test sensors. Then I was going to do a test in the lab with the atmel. So it'd be a power test. So we don't need our battery and our solar panels yet. This is just done inside the lab with a power supply in the lab. So we actually decided that this testing was not going to be part of the atmel development work package. So I actually got the numbering wrong here. This was 7.4. 7.4 was atmel lab test. And then after that, we were going to do a beta test. So this is like the final test before we commission. So that's 7.5. And then we're going to need to commission at some point. So this is the final step over here is commission. 7.6 commission. So let's go back and look at our other task here. So I'm going to draw some arrows in. Yep, all good. So with this battery, the solar panel, and the regulator, I want to do some sort of power test that didn't involve the atmel, so separate from this. So I'm going to draw a box here, 7.1 power test. And so to do that, I need the regulator. I'm going to need the solar ready, and I'm going to need the battery. So I can do a power test of that. I don't need the router for the power test. So assuming that power test goes well, we then need to connect everything up. So we've got a stage here, 7.2 connect router. To do that though, we need that router installed. So there's an arrow here, dependency here. So that's a predecessor to this connect router. Then I want to do a field test without the atmel. So a field test with our battery, solar, regulator, and we're going to include the router in that as well. So basically those items are powering the router. So this is another field test, and this is where we switch numbering here. We went to 7.3. And then that will feed into the final beta test. And this is where we're actually finished, stop, end of the schedule. Yeah, so that, my interpretation of the dependencies between the activities here, so you could consider this to be a network diagram. You could do it in many different ways. This is a design process, so other engineers may invent your network diagram in a different way. But the key point is to look at the dependencies, and here you can see that there will often be multiple dependencies. So in order to do this power test, I needed to have the battery charged, the battery ready, I needed to have the solar installed and ready, and I also needed to have the regulator ready to go. So next off, we're going to look at the critical path and also the length of time that's going to take to complete this project. And so to do that, we need to go into a bit more detail. And so we're going to start with a new version of this network diagram. So we did our network diagram, but now we need to actually do the calculations for the length of the project and also the critical path. And we do that by drawing this, but then also we're going to do a forward pass and a backward pass. And this is called a critical path analysis, CPA. And so in order to do this, this is just a technique that you can use. Essentially, for each activity that we drew on that network diagram, we're going to draw a box like this. And so it's normally just a 6 box like this, but I like to put in this top line as well so I can write in the activity. So let's do the first one. The first one was order battery. And so our work breakdown structure number for that was 1.1. So you put that in the middle. And then also I've decided, well, let's actually try and figure out the duration. So the duration goes in this box down the bottom. And I know that the battery is not going to arrive immediately. So I'm going to have 7 days to order the battery. And so I'm going to do this for, it's going to take a little bit of time, but I'm going to do this for every activity. So we had 6 running down here. I draw these boxes, 1, 2, yeah, let's do the next one. So I'm going to try and do this fairly fast. It might be a little bit messy, but you should be able to understand what I'm talking about. Okay, so our second task was order solar, and that was 2.1. Our third task was order router, and this was 3.1. Our fourth task was order regulator, and that was 4.1. Then we had order sensors, it was 5.1. And then we had order atmel, 6.1. So I'm just going to do this for every activity, and then we can do our forward and backward passes. So our next activity here was to charge battery. I decided that was 1.2. I decided charging the battery is not going to take long, so it's 1 day. This next task was install solar. That was 2.2, and that was going to take 1 day. It's not long to set it up. This task was install router. So of course you do this on a computer. I'm doing it like this in order so you can see exactly each step that I'm doing. Seemed to be the easiest way to do it. So this is 3.2. I decided installing a router is not going to take one. That's 1 day. And before I forget, I haven't done durations for all of these. So order solar. It actually takes a long time to get the solar panels at the moment because they're probably coming from overseas. So I'm going to say maybe air shipping, 14 days. The ordering the router, that can be picked up locally, so I'm going to do 3 days, might be faster. Order regulator, it's going to take a bit longer, so 7 days. Order sensors is going to take a long time because there are multiple sensors coming and they're a specialist item, so that's 30 days. And ordering the atmel is 7 days. So my next task was down here. This was connecting up sensors. Task 5.2, and it was going to take 2 days. And then down the bottom here, after ordering the atmel it comes in, the first thing I'm going to do is our application setup, get stuck into the programming. So that was task 6.2, and we actually need a long time for that. It's going to take 30 days to do that. So while we're here, let's draw in some arrows. So order solder, install solder, order router, install router, order sensors, connect sensors, order atmel, app setup, and then let's keep going along with the atmel. So we're going to program our sensor libraries here. So this is task 6.3. It's going to take a long time to do that, 14 days. And to do that, we need to connect the sensors up. So this is a dependent task here. So once we've done our programming, we're going to test sensors. (6.4) and testing of the sensors is only going to take 2 days. Then we wanted to do our lab test of the atmel. So a proper test, and that's in the lab. So we don't need our battery or solar for this. Lab test, and that's 7.4, and it's going to take 14 days. We're going to run the test, let it run overnight for 14 days, so we can measure, because it is a weather project, a weather sensor, so we can measure humidity, rainfall, and temperature over an extended period. Okay, so let's go back to, we're going to do a power test. So this is a box here, power test. This was 7.1, and it's going to take 3 days to do this power test. So to do the power test, we're going to need our solar for that. We're going to need our battery ready. And we're going to need our regulator. Next off, we're going to connect the router. And that was task 7.2. That's going to be fast. It's going to take 1 day. So that's done after our power test. And to do that, we need to have the router ready to go installed. And so we've got our router connected to our solar, our battery, and our regulator. So we can now do our field test. So that was 7.3. And it's going to take 7 days to do that. And then once that field test is done, we can do our final test with everything together. I've called that a beta test. That was task 7.5, and we're going to do a really long test, so 30 days for that. And then finally, once we're happy with our system, we're going to commission it. So install it out in the field, have it ready to go. You start collecting real data. So that was 7.6. It's going to take 2 days to do the install. So I haven't done all the arrows here. So atmel, lab test, the beta test is after that. After this field test, the beta test is after that. And we're done with our network diagram. So this is the same shape and size as the previous network diagram we've done, except now we have the numbering in there. And we've got plenty of space here with these empty boxes to do our backward and forward pass. So to recall what these 6 boxes are, I'm going to draw this up here. So up the top is activity. So this is our activity number, like 1.1, 1.2 from the work breakdown structure. One underneath is duration. This is ES, so early start, early finish, and late start, late finish. So in our forward pass, we're going to fill in the 2 up the top, the early start and the early finish. So without ordering the battery, the earliest start is going to be at day 0, and plus 7 days. The earliest finish is 7 days. So that gets fed forward here. So 7 days plus 1, 8 days. Let's just do this first side first. So they're all going to start at 0 day, right? So I'm just going to run down here and put 0 in all these. It's going to take 14 days. It's going to take 3. It's going to take 7. It's going to take 30. It's going to take 7. come back here, order solo. So day 14 goes across to here. So it's the earliest start is day 14 for the install. Add 1 is 15. 3 here plus 1 is 4. Here, 7 days to order the regulator. So we have to be careful here because there's 2 arrows coming in. This is 7, this is 15. You have to put in the biggest number because we can't start until day 15. So there's some slack in here. And so 15 plus 3 is 18. So then we go to this box. So you can either start on day 18 or day 4. Well, it's got to be day 18. Plus 1 is 19. There's only 1 arrow here, so you go across 19. Going to add our 7 to 19 is 26. And before I do this bit, I'm going to come back here and finish off. Okay, so ordered sensors, 0 to 30. 30 goes here. Took 2 days, 32. Ordering that mold took 7 days. Put the 7 here plus 30 is 37. Oh, arrow here. 37 or 32. Well, 37 is bigger. So the earliest start is 37. Add 14 to that is going to be 51. There's only 1 arrow, so 51 plus 2 is 53. 53 plus 14 is 67. And so going in here, we've got 67 and we've got 26. It's going to have to be 67. Plus our 30 days is 97. So 97 plus 2 is 99. So we've completed our forward pass. So the project is going to take 99 days. So project length or total duration, 99 days. So now we need to do our backward pass so we can work out the critical path. So remembering what the critical path is, it's the path through the network where there's no slack. So if any of the activities on the critical path get delayed, it means the project will be extended. The project will also get delayed. So we need to identify the critical path so we can make sure we can prioritize and keep those activities on task because there's no slack or float in those tasks. So backward pass. So we start at day 99. So it's going to be 99 minus 2 is going to be 97. So there's no others feeding in here. So this is going to be 97 too. Takes 30 days. So this has to be 67. So this is 67. That's going to go up here. 67. Same for down here. 67. 67 minus 7. This is going to be 60. Passes back to here. 60. 60 minus 1 is 59. So just if you think about this, 59 is the latest start date and the latest finish is day 60. So we'll keep going back. This is going to be 59 here. 59 minus 3 is 56. And while I'm here on this one, 59 is going to come here. Minus 1 is 58. So what about this one? So this was 56 here. So 56 has to drop into these two. So now we can start at the top here. So 56 minus 1 is 57. 57 here minus 7 is 50. So 56 minus 1 here is 55. 55 minus 14 is going to be 41. 59, 58. 58 minus 3 is going to be 55. 56 here. 56 minus 7 is going to be 49. Okay, so let's do our atmel run. 67 minus 14 is going to be 53. 53 minus 2 is going to be 51. 51 in here minus 14 is going to be 37. So 37 also goes up here. 37 minus 2 is 35. 35 minus 30 is 5. Come back down here. 51 minus 37 goes in here. Minus 30 is 7. 7, 0. Okay, so you know it's your critical path because these numbers, top and bottom, so the early finish and the late finish are the same, and the early start and the late start are the same on the critical path. So it's going to be this guy here. Yeah, it's going to be this guy here. These are different, right? So actually the critical path is down the atmel route. So if it's going to be here, it's going to be here, here. What about up here? No, it's going to be this one here. Okay, so we found our critical path. And so let's have a think about this. So if we actually went up to, say, the battery, the earliest start to order the battery is day 0, but the latest start, you actually don't need to order this battery until day 50 at the very latest. So you have a slack there of 50. What about this one here, ordering the router? We don't have to order the router until day 55 at the very latest. Not that you'd want to do that, you want to order it early, but you have plenty of slack up your sleeve, and then so forth. So it does give you an indication of where the slack is here. So the slack in here, here, and here, this is the critical path. And so this is a simple example, but this quickly spirals out when you have a big project where you're doing things more than just ordering, when there's actually a complicated set of activities that need to go into any project. Consider doing this for a house, for example, would be extremely complicated. So that's how you actually do a network diagram. So this is similar, or it's the same data that's used in a Gantt chart. And so when you create your Gantt chart, I've actually prepared this earlier. So this is the same thing. So here, I'm sorry, it's a little bit messy here, but these are the items that were on your work breakdown structure, so the same numbering. And here I put in the predecessors and the duration. So these are the durations. So these are taken straight from our other network diagram here, but then you can work out the predecessors. So if I bring this over here, if you look at, say, charge battery, its predecessor is 1.1. So I put 1.1 in there. Let's do a more complicated one. So let's look at this power test. It's got 3 going in. It's got 3 predecessors. So its predecessors are going to, of this power test, are 4.1, 1.2, and 2.2. And so when you finally go through the network diagram like that, you'll have your numbering, your activities, your durations, and your predecessors, and that's what you need for the Gantt chart. So you can plug that into software, and the Gantt chart will be generated along the same lines as this network diagram.